In this short tutorial, I am going to walk you through how you can download USGS streamflow data using Python, and specifically using a Python package called Hydrofunctions. Hydrofunctions is a library in Python. I have provided the website for you right over here. You can click on it and learn more about features. I have summarized the features in this document for you, but if you want to learn more and take a look at more tutorials, they have a great repository of tutorials in their website that I highly recommend. Before I get started, you can find this tutorial, this Google Colab notebook, in the websites that is linked in the description section of this video. So I highly recommend that you click on that and follow along as I run the code. You can run the code as well and change it as you want to. Another thing that I want to mention, that I have written step-by-step tutorial of every single code cell. So in this video, I'm not going to go through all the details that I have written over here, but I'm just going to go give you an overview of how the code can be run and an overview of the results. Okay, so the first step, as always, is going to be to install Hydrofunctions, this Python package. When you run the cell, it is going to automatically install the package for you. Some of the libraries might already be satisfied, some of them might not be satisfied, so it will take usually a couple of seconds for Google Colab to run this installation cell. And I'm going to close it. We don't need it anymore. Okay. The next step is going to be importing Hydrofunctions as HF. This would be the short for it. And then we are going to use matplotlib inline this magic function to make sure that all of our graphs are going to show up in line. I'm going to run that as well. All right. The next thing is to downloading USGS stream gauge data. In order to do that, well, you can read all of this description over here. I'm going to explain it right over here. So we need to have a site number, and this is a USGS gauge site number. Specifically, this one, for example, is related to St. Paul. If I'm not wrong, this is the St. Paul station in Mississippi River Basin. I think I'm correct. There we go. St. Paul station at Mississippi River. The other thing that I want to mention is that HF is hydrofunctions.nwis. It is going to connect it, as I have actually explained over here. It's going to connect it to USGS National Water Information System, NWIS, and automatically retrieve and download the data for you. Okay, I have two lines over here for data. One of them is commented out. The reason that this is commented out is that I wanted to show you how you can retrieve different sort of data. First of all, DV stands for daily values. So if you want daily values to be downloaded, you are going to write DV over here. But if you want instantaneous values, like hourly, half hourly, 5-minute, depending on what data is available, you need to use IV, instantaneous values. I have actually written that over here for you as well. Okay, and then for the period, right now I have P5D. So this stands for previous 5-day. You can change it to previous 10-day, previous 20-day, previous 365-day, so on and so forth. This is one way of retrieving data. The other way would be by specifically mentioning a start date and an end date over here. Okay, this is another way. So if you prefer to run the other one, just comment the other one out and uncomment this one. Okay, but for this tutorial, I'm going to use the daily values for the previous 5-day just to show you. Okay, this line of code over here, it prints that essentially the data have been downloaded successfully, and then in this line of code, it is going to put the data into a data frame, a pandas data frame. And this, later I'm going to talk about it, what this code is. Essentially, this code represents streamflow. So in USGS NWIS, this code 00060 represents streamflow discharge in cubic feet per second. Okay, and then over here, I'm saving the data into a CSV file by providing the format of the date for the data. Let me run this. I'll show all of these to you. So I'm going to run this cell. You can see that the request has been sent to this website, which is USGS website. And essentially, now if I go to this folder, you can see that the data.csv is downloaded. If I double click on it, you can see that the data for the last 5 days, because P5D has been downloaded right over here. Okay, so now the other thing is, how do I know about this number over here? Okay, well, before doing that, let me change this instead of DV to IV so you can see the instantaneous values too. When you run it, well, right now we get an error for the last 5 days. Let's see what the error is about. Oh, okay, so this is essentially a warning. So it's about the sampling of the data that is available. So essentially, if I run this again, you can see that right now, in addition to, I have multiple pages because for every 5 minutes, I have essentially data right over here, okay? Now, if I turn back to daily value, okay, and run it, okay, as I told you, 00060 represents streamflow. Now, if I run print data, it tells you that this code represents discharge cubic feet per second, and it gives you the start date and end date. So this is a good description of this station that I told you, St. Paul, Mississippi. Now let's do this for instantaneous value, IV. You will see that for instant, and again, this is not an error, this is a warning, sampling warning. You can disregard that. If I run this again, now you can see that in addition to discharge, there are other things available too, like water temperature, gauge height, stream water level elevation. So if you want to save other things, you also can. Like here, instead of having your discharge, you can change it to 00011, and that will give you the water temperature in degrees Fahrenheit. Okay, so I just want to show you that it's not just streamflow. You can download whatever you want to if the data is available. All right, for the sake of time, I'm going to change this to DV again, daily values, and then run this. Okay. Now, the next thing that I want to talk about is, remember that I used the number over here. There are other ways of calling the discharge data. You can explicitly write discharge and it will give you the discharge. So I'm running the head, which is the first five rows of the data. So if you run that, you can see that this is the discharge given to me. Now I can do 00060 and run it, and it again gives me the same values. Another alternative would be using Q. Q in hydrology and hydraulics represents flow, right? So if I run that again, it gives me the same value. So these are different ways of calling discharge. You can use the discharge value, Q. Oh, I think D should be lowercase. There we go. Okay. Discharge, lowercase q, or 00060. These are the codes for calling discharge. Okay. Now, Hydrofunctions give you the ability to plot the data as well. So let's plot the stream flow for the last 5 days. This would be the stream flow for the last 5 days in Mississippi River. Okay. The other thing that I want to talk about is description of the data. So essentially, what you can do is run .describe method on this data frame that you have created, and it gives you the count of the data. Well, it was the last 5 days, so we know that. Mean of the data, standard deviation, minimum, and then it's going to give you the first quantile, 25%, median, and the third quartile of the data. Okay, so this describe is very useful to understand your data. Okay, the other thing that I actually showed you above, but here to repeat, you can save the entire data into a data frame. So I'm running that, and then you can print the head of the data or the first five. Now, notice that here I did not specify what I want. Essentially, I didn't say that I want only discharge. So because of that, it gives me the qualifiers as well. Um, what does this mean? So P essentially means provisional data. Okay, that means it has not been approved by USGS yet. Okay, but it's provisional. Okay, A is approved, and there's AE, that is approved and estimated. That usually happens in winter in the areas that the surface of water is frozen. Okay. Um, and then, as I mentioned, you can save the data as well. So if I run this code cell, you can see that the data right now is saved and the qualifiers are saved over here for it too. Okay. The other things that I want to show you, if you want to see the flags specifically for a specific sort of data, right now for discharge, I want to see the flags or the qualifiers. You can do that, and it gives you the qualifiers for the data too. So this is another way of seeing those flags or the qualifiers. Okay. Now, there are different ways of downloading the data. What if you want to download the data for multiple stations, not just one? What if you want it for a region, right? So let's talk about that. The first thing that I want to talk about is what if I have a list of different sites. Right now, these two numbers are USGS gauges for the Red River Basin located at Fargo and Grand Forks, North Dakota. Okay, so I've created a site list and I've put these two gauge numbers over here, and that's my site. Again, I want to do daily values. This time, my start date is sometime in 2010. My end date is sometime in 2020, okay? And I'm printing the data to show you what data is available for this, okay? After running this code, it's going to connect to NWIS, and it tells you that for this station, which is located at Fargo, you have access to water temperature, discharge, gauge height, specific conductance, dissolved oxygen, pH, turbidity, so on and so forth. And this one is at Grand Forks, and this is the data available. Excuse me. And this is the time period that essentially we wanted. So all the methods that I showed you, plot, describe, can be applied now to this one as well. But remember, because you have two sites, now if I plot this, you are going to get two lines. Look at that. One of them is going to be Grand Forks, because I know the number. So the orange one is Grand Forks and the blue one is Fargo Station. Now, if you have 10 stations in your list over here, you're going to get 10 lines right over here. Okay, the next thing that I want to talk about, what if we want to create a box on the map and let the program figure out if there are any USGS gauging stations available in that area, and if they are, give us a list and then plot them, okay? So this explains all of that. The bounding box is easy, so you need to create a list that has the longitude and latitude of west, south, east, and north for that box. And then the parameter that we want is, you remember this number by now, this parameter is your discharge. Bounding box is the box that I have created over here, and the period that we want to is the last 5 days. So for that box is going to request the data, and now if I plot it, it is going to give me two lines actually, essentially, for it looks like the data for this line was not available. Okay, that's why I only have two lines for this period that I have last 5 days that I have specified. Okay, now here you defined your west, south, east, north. There is a way that you can essentially automate that process. So I have used IPy leaflet over here to draw my box. So now you're going to see over here. So what I'm going to do, this is the Minneapolis area. I am going to, let's say, draw a box right over here. Hopefully there is going to be one USGS gauging station somewhere over here. And this is gives me the boundaries of the box, but you don't need to do this because it automatically is going to incorporate that box into this one. And I'm going to run this data. Let's see how many, let's see if there are any USGS gauging stations. So as you can see, there are no USGS gauging stations right over here. Does not have any data. Let's try it again. I am going to clear the box, zoom out a little bit. Maybe this time I will make my box bigger. Let's zoom in the St. Cloud area and make my box a little bit bigger. Okay. And run this code again. This time, hopefully, we are going to get some data. There we go. So how many stations? We have 1, 2, 3 stations in that box. Mississippi River at St. Cloud, Sauk River, hopefully I'm pronouncing it correctly, and then Mississippi River near Royalton, Minnesota. Okay, now if you plot it, if the data is available for that period, it is going to give us. So 3 of them are available, not for the entire thing. Like the orange one is only available, looks like, until 2018. The blue one and the green one are very similar to each other. Okay. Another useful thing would be, now, what if I want all the USGS gauging stations in a state? Okay, so let's say that the state that I am looking for is Minnesota, and in Minnesota, I am looking for discharge, and I want the past 50 days of the data, and the state code is what I defined over here. Let's see how many stations we have. It should be a lot of stations available. So as you can see, it gives you the list of all of these stations that meet the criteria that you defined over here. It's a lot of stations. Okay. You can do all the methods that I showed you before on these list of stations as well and save the data too. Another one that is useful is by county code. So if you click on this website over here, FIPS, you will be directed to a website that gives you the county code for every county in each state. If you get that county code and bring it and put it in over here under county code, it essentially reads the county code and is going to download the discharge for you for the period that you have asked. Now, if you print the data, it shows you how many stations meet that criteria and shows you a list of stations that are available. So it looks like in that county that I just showed you, there is one in this number, which is in a county in Minnesota. There is 2 USGS gauging stations available. Okay. And then now that you have the data, you can essentially do some analysis on that. The first thing that you want to create is the flow duration chart, okay, or flow frequency chart also. I'm going to run this code and I will show you what I mean. Okay, so this is the probability of the exceedance. Obviously, the probability starts from 0 to 1, 0 to 100%, if you will. And then the discharge is on the x-axis of this. So for each station, you'll be able to create this probability of exceedance and essentially figure out the probability of exceedance of a specific flow that you have. Now, you can change the scale of x and y. The scale of y by default is logarithmic. If you want to change the scale of probability exceedance, instead of linear over here, you can do log and run it, and you will see that there we go. Now the scale of probability over here is again logarithmic. Only the scale changes. Obviously the values change also from 0 to 1. So I'm gonna change this back to linear and run it again. Okay. The other thing that is very useful, specifically if you are a beginner using Hydrofunctions, would be using the help function. So if you put this HF flow duration or any method that comes after HF, like describe, in the help function and run that, you will see that it will tell you what that function does, and then how you can use different strings or values inside that function. Okay. All right. And then the other thing that I really like is the cycle plot. Cycle plot gives you a good overview of the long-term flow if you have that long-term flow. Okay. Now, in order to create the cycle plot, you need to specify how you want your cycle plot to be plotted. Actually, let me run it. It would be more clear to show you that. Okay. So now you can see that the mean over all of the years that are available, I think it was from 2010 all the way to 2020. The mean of flow in each month over this 10 years of data is the blue line. The median of flow is the dotted line, okay? And the gray area is essentially gives you another statistical representation of the flow. Just to learn what they are, you can put hf.cycleplot into the help function and run it, and then it tells you essentially what these specifically return and how you can interpret what you see. Over here, for example, I selected annual month, and right over here, you can change that frequency, the cycle, to the smallest one possible, to annual day, so on and so forth, to learn more about your data. And then as you can see, the gray stripes represent the 40% and 60% quantile, and the 20% and 80% quantile ranges, okay, different shades of gray. Okay, so this help function is very helpful as well. If you want to generally get help on the hf.nwis, similarly, put that in the help function, run it, and it will tell you a lot of good information about that NWIS method and how you can specifically change that and tailor that to your needs. Okay, so this was a very short introduction to Hydrofunctions. I highly recommend checking out the website that I have in the description section of video to learn about more and upcoming Python tutorials that I will be putting up soon.